So in 73, we're given three zeros, and we're supposed to find the polynomial given these. So the first step there is to turn these zeros into factors. So let me list them out. X equals 2, and 4 plus square root of 5, 4 minus square root of 5. So let's get them into factors. So x minus 2 is a factor, and then of course all three factors will get multiplied together. Now when you subtract this term, that's going to be x minus both of these. Maybe think of just doing one at a time. So minus 4 minus square root of 5. And this will be x minus 4 and then plus square root of 5. That might be the easiest way to keep track of this negative signs. That's usually the biggest mistake, is these negatives and positives, getting those correct. These two trinomials will be the trickiest part, and since they are coming from conjugates, a lot of things are going to divide out or cancel out as you expand these. So I would really recommend you start with these two together first. Anytime you have two conjugates you can multiply together, always do that, because you're going to see a lot of things disappear. Otherwise, the work just gets really complicated. So I'll bring this down and I'll simplify this part out. Let me do it in a different color so it hopefully kind of stands out. So x times x is x squared. X times negative 4, x times square root of 5. And I'm going to put the x first because I don't want it to look like the x is underneath the radical. That could mess things up. All right, negative 4 times x. Just try to line things up. That helps too. Negative 4 times negative 4 is plus 16. Negative 4 times square root of 5. All right, and notice how these aren't lined up with anything yet because they didn't really fit anything else I had in the first part. So negative square root of 5 times x. All right, I'm going to put that underneath this one. They're going to subtract that in a moment. All right, positive 4 square root of 5. And then negative 5. Two squareds, well, they cancel out basically, so minus 5 there. So this is going to become x squared minus 8x. These add to 0. That becomes 11. And these add up. And then I'm going to bring the x minus 2 down and expand one more time. So x times x squared, x times 8x, x times 11, all right, minus 2x squared, plus 16x, minus 22. Put all this together, it's going to be x cubed minus 10x squared, plus 27x minus 22. If it's supposed to be a polynomial or a function, it's really important that we put f of x in front of it. So in 89, I've really shorthand the directions here, but basically we're taking this polynomial or this function and we're going to graph it by hand. It gives us a lot of pointers on how to do that. One of the first things is to find the zeros. So I'm going to start that process. I'm going to take this polynomial, set it equal to 0. And I'm going to go ahead and do a u substitution because I think that'll make things easier. You can get by not doing that, but I just think it's probably a little bit easier here. And it's something you need to get used to that for calculus anyway. So the u substitution is happening because this is not the typical x squared x and then constant trinomial. It has x to the fourth and x squared. So I'm going to take the middle term, which is x squared, call that u and see if it works. And if it does, then we're good to go. So if I call the middle term, or the middle variable, x squared u, let's see if this format is going to work out. And if it does, we're good to go. So x squared would be x to the fourth, that's good. Just plugging in x squared here would be good. So that's going to make it work. And I really want my u substitution to give me something squared, and then just u here, and then a constant at the end. That's the format I'm really looking for, because that's our normal trinomial. All right. However you want to factor this, the factors of 1 times 20 to the negative 9, when you add them, would be negative 5 and negative 4. So this would be u minus 4 and u minus 5. So u would equal 4 and u would equal 5. I'm trying to solve this. Just make sure you do solve for x. So x squared would equal 4. x squared would equal 5. So x is plus or minus 2, x is plus or minus square root of 5 when I solve it all the way down. Okay, now I was doing more than solving. I do eventually want to do the graph, but that's one of the first things you need to do. So I'm going to draw just kind of a sketch over here by hand and put these zeros on it first. So positive and negative 2, here and here. And then positive and negative square root of 5. So I'm not going to get too picky on that. Square root of 5 is bigger than 2, it's less than 3, so I'm going to put it kind of in between. And that's really all I'm looking for at this point. All right, now let's take a look at end behavior. And if you notice, my graph just magically changed just because I realized that it was originally negative here in the beginning. And I probably should have told you this about solving. Always make sure that you have a positive leading coefficient when you go to factor or solve. It can really throw things off if you have a negative leading coefficient. It can be done. It just makes things a lot trickier. There's more to keep track of, and it's just way easier if you have the leading coefficient be positive. All we've got to do to make that happen is just multiply everything by negative 1 on both sides. 0 times negative 1 stays the same, and multiply by negative 1 here just changes all these signs. That's all you got to do. For end behavior, though, because it was negative leading coefficient, and we had a even polynomial, both ends are going to point the same way. And let me back up. Because it's even, both ends point the same way. Because it's negative, that means they both point down. If it was positive up front, they both point up. So both ends are going to point down. So I'm going to do this from the last 0 I have. Because from that point on, let's consider the one on the right. From that point on, it's going to be going down forever. From this point on, it's going to be going down forever. Okay? One more thing, it says find solution points as needed. What that means is go through and plug in whatever you need to. If you want to plug in negative 1, see what you get, 1, see what you get. I'm going to look for the y-intercept because I think that's pretty easy to get. The y-intercept happens when I plug in 0 for x. When I do that, everything goes away except for the negative 20. So this will probably not quite be to scale. I'm just going to put a negative 20 down there for the y-intercept. And that's really all I'm going to do because at this point, I know what my end behavior looks like. I know where my zeros are. So that means it's going to come up above the y-axis here, or x-axis here. And then it's going to go back down until it gets to the y-intercept. And it's going to come back up. And that may not be the minimum, but it sure does look like it probably is the way this is really symmetric. And I'm not really worried about whether you get the maximums and minimums in the right spot right now. That's not a really big deal. I just want to see that you get the general shape of the graph. So this will be good enough. I'm looking for the zeros and at least one other point somewhere, which the y-intercept's a good one to put on there usually. And then that would be good enough for your shape.